We are Arbe Robotics. We are bringing the power of radar to autonomous driving. What we see is in the next 10 years, the automotive industry is going through a disruptive transformation. The mobility is becoming electric. It's becoming connected. The cars are talking to each other. You saw it earlier. The cars are being shared by people, like you see in Get Taxi presentation. And I think that the main thing that is happening is that cars are becoming more and more autonomous. But those changes takes time. And the road to autonomous future, as we see it, is long. But on the way to autonomous, there is a major increase in the safety features that are in the car. And when we started our company, our main goal was to build a product that will be good for autonomous car, but can fit into the car today and preventing accidents from occurring even in today's cars. So as we see it, in 5 years, we will see safety features, what is called level 3. So the car will be able to drive autonomously on the highway, even to pass lanes. Inside the city, it would be able to make autonomic brakes if there is something that is really dangerous. On the other side, there will be few tests and few beginning of services of robocars, mainly in a campus, in closed areas, or in designated cities. And in our estimation, the full autonomous private cars will happen only on the next, in the middle of the next decade. So basically, if you're reading TechCrunch, you might think that the problem is already solved. There is a car of Google, Waymo, driving in Silicon Valley. There is one of Cruise, GM, driving on Silicon Valley, so the problem is solved. So the problem is not solved, because this is what happened when you open the baggage of this car. You see this amount of sensors and processing that is located out there. There's no room for stroller, for example. So there is few things that need to be changed dramatically in order for those cars that are right now not more than a mock-up or a demo will be able to really drive safely. So first of all, small truth, those cars, 20–25% of the time, are driven by a human driver. This is when the conditions of the road are not allowing the car to drive fully autonomously. So first of all, the sensors must work 100% of the time. So you need a sensor that works in any weather, any lighting condition, fog, rain, pollution like in Beijing. Nothing can hurt this sensor. So the only sensor that is doing that is a radar. Secondly, you need to get rid of all of those servers and make them processed on a small chip like in our computers or in our mobile phone. No one will drive with such amount of electronics inside his baggage. So also those processors and sensors cost today more than $100,000. This is not realistic for anything. So this autonomous suit should the price of it should go down below $10,000 for the car manufacturers. This is the three main challenges of the industry before autonomous driving can get into the real production. All of this also requires massive training of the algorithm. So after we will have the sensors and after we will have the processing, there's still need for a training set. And this is the reason why we think that it's not behind the corner, and for a real production, it will take time. So our vision is to build the eyes and brain for the next generation cars, and we are building it upon a radar. Radar is an old technology from World War II. It's exists in cars for more than 15 years. And basically, radars in the military are the ones that already detecting the missiles that are shooting on Israel and making all of the complicated decisions. So the gap that we wanted to solve is to take the radar, the big radar of the military, and put it on the size of almost a mobile phone, and on a form factor of a mobile phone, and on a price point that can get into a car. And this is what we are doing. Because today's radar on the car are really on this size, but their resolution is poor. So for example, all of the people here in front of me would be look on the radar as a one big, massive amount of a point, and not separated. And our radar can separate between them. So it's the first radar in the world to actually show in real time driving on a car the resolution that is needed, that is must for autonomous driving, and this is the spec of the automotive industry. We are implementing our technology on a chipset of silicon. We have 3 chips, transmitter, receiver, and our ASIC, our dedicated radar processing unit. I will try to show you a live demo of our technology from near of our office in central Tel Aviv. So you can see here 2 cars parking. You can see them clearly on the radar picture. The line there is what is separating the road. It's in Hashmonaim Street, between the 2 sides of the road, and this is what is happening when we're... So you can see clearly that even if there is a motorcycle or if there is a car on this side of the road or on the other side of the road, no matter how close to they are, we are able to track them, to classify them, to say if it's a motorcycle or if it's a car, and if it's even a human being. And take a look what is happening now. There is a car stopping in front of our radar, and we are still detecting what is happening behind the car, and also what is happening on the other side of the road. This is the power of radar, and because of that, this is the only technology that is really 100% proof for safety features. Sorry. So on top of it, we are doing what we call smart fusion. Our radar is pointing the other sensor in the car, the camera and the LiDAR, just to the areas in the environment that there is actually things that it needs to detect, and by that reducing the power consumption. 2 words about ourselves. We are 2.5 years old. We are 45 team members, 5 of them PhDs, 10 provisional patents. We raised $13 million till now, and most importantly, we have 7 customers that we already delivered them our first product, and they started drive test with our product. If you want to join this amazing revolution, please contact me soon. Thank you.